Hey, I'm Bob Benz. I'm giving you a presentation on Excel as a human-machine interface. Give you a little background on my business. We got into the boiler business quite by accident. Started back in 1985 when I was doing a research project for Southern California Edison, modifying a boiler with non-selective catalytic reduction system, which is car catalyst. We were putting catalyst in the back end of a boiler breech and then running the boiler stoichiometric. And to do that, we had to use variable frequency drives to control the combustion air fan, essentially matching the parabolic system of a fan with the parabolic system of a boiler and running the fan speed as a function of fuel flow. That project was it was a failure. It didn't work. The catalyst was not really suitable for a boiler. It wasn't right temperature. Couldn't maintain the homogeneous mixture into the catalyst. But quite by accident, we discovered that by passing a mixture of flue gas and air through the fan and running that fan as a function of fuel flow, much like what we needed with the NSCR catalyst, we could get to very low knobs. And in fact, way below 30 ppm, like into the low teens on some of these boilers with the existing burner, basically proving that the low NOx burner business was somewhat of a fraud at the time. And we decided to commercialize this product. We called it the CompuNox system after a couple shots. And we decided to commercialize it. And basically, it's a control system. The control system at the time, when we first started, was based on a DOS-based system. We used a 486 PC that was running DOS 5.2 at the time, and programmed it in Microsoft Excel using ISA-slot input and output cards that we would peek and poke to turn things on and off. Did the whole thing in DOS, build a little screen with shapes and lines and fill functions, and it was just a 640 by 480 screen, and then we put a bezel on it for a touch screen so we could push buttons and stuff like that. And then along came Windows 3.1. And due to the dreaded blue screen of death that was prominent at the time, we decided to pull the control, the mission control stuff, put that in the PLC, program that PLC, and then basically interface with a Visual Basic 3 screen at the time. That's a 16-bit programming language. And we developed the screen for that, basically communicating between the PLC and the PC through an RS-232 link. And then after that, there was Windows 95 and then Windows Me. Oh boy, that was amazing. But anyway, and then XP. And with that advent to the 32-bit platform, they got rid of Visual Basic 3, went to Visual Basic 5 and then 6. And that was a 32-bit platform, pretty easy and simple to because it was cross-platform. Just take the screens that we had in VB3 and move it over to VB6, and we were done. And that worked pretty well, and it had a lot of advantages. Some of the advantages of Visual Basic at the time was that it was widely used as the platform in which the HMIs at the time for RSView, Inolution, Wonderware, they were all written in Visual Basic 3. So it was something that was sort of an industry standard programming language at the time. And of course, people that had Office, they were using Visual Basic 6 because that's the back end of the macro of Office. It's in Excel and Word, and it was generally accepted as a reasonable HMI for most people in industry and commercial applications. These are some of the screens that we made. This screen right here was Miller Brewing in Milwaukee. Big 150,000 pound an hour boiler, 400 psi, 750 superheat. We basically made this screen with all these were labels that we would update through an ecom interface. We would communicate through an Ethernet connection to these PLCs and pull in the data and then populate the screen. These buttons were add-on ActiveXs that you could buy and import them into Visual Basic. It was actually pretty simple. We had like these face plates for the boiler master and the drum level control. Those were also third-party add-ons to Visual Basic 6 that we were programming in. And then came Windows 10. And Windows 10 got rid of the VB6 and went to Visual Basic.net. That was the big thing that Microsoft was pushing at the time. And that required a whole rewriting of the Visual Basic 6 code that we had. We had to redo all the screens. And, you know, even after doing that, there was some friction with customers and using VB.net. They had their particular HMI platforms that we're using, be it RSView or Inolution Wonderware or the host of other ones out there. And so we started thinking, because, you know, the thing about all of these HMIs, they all export to Excel. So we decided, well, why don't we stick with VB and just use Excel? I mean, it has a lot of advantages to it. First of all, everybody has it, and it's inexpensive, easy to use, simple, has a whole bunch of add-ons that you can add for taking data from remote locations, sticking it on the Excel. The big disadvantage with using Excel as a HMI is that nobody's using it, and so that was one of the things that we couldn't figure out. In fact, I don't think anybody's using it except for us. But you know, there's so many different things that were advantageous in far as going to Excel. First of all, one license does it. I didn't have to go out and buy all these licenses for Inolution to do one customer and then RFU to do the other customer, or Wonderware to do the other customer. Wonderware, where did they get that word? Anyway, and plus there was a cross-device compatibility. I mean, Excel is inherently data logging. I mean, it's easy for it. And anybody with Excel can use it. And there's no tag limitations, and it's simple. So we decided to use the Modbus because the second one points it out here. It basically, everything that's like microprocessor driven, VFDs, they all have a Modbus communication backbone to it. And so you can like pull a VFD and pull data back and actually set points by throwing, you know, via typically ours 485 link up to those. And plus, there's like at least 20 different vendors out there offering these ActiveXs that you just plug in the Excel, and then you can pull via Modbus any PLC, microcontroller, you name it, you can pull it in. So then what we did is we designed a screen, and this is a screen that we had designed. This is for a boiler 2, I think it was a Tascadero or whatever. But basically, we, instead of the labels that we're using in the old Visual Basic 6 code, we actually populated cells, and we dropped on like buttons on the screen, and all of that on a startup are already placed in. So we actually put them in, and by adjusting the cell height and width, we can make it to any screen width. You can get rid of all the, you know, the menu bar and everything just by a couple functions in Visual Basic. So it basically mimics what we had in Visual Basic 6. The system that the ActiveX that we set upon was the MBAXP, which is WIT software. Has it's really inexpensive. It's like $90. You get a license, unlimited runtime, has the three variants for protocol, which is like the RTU, the ASCII, and also the Modbus TCP, and it has all the supported Modbus functions that is part of the Modbus criteria of like communication. You're going to read the coils, which are the buttons, and then you read holding registers, which are like analog inputs. By the way, analog inputs, floating points are 2 successive bits, so you have to skip every 2. It's not that big of a deal, especially in Excel. So the setup of this thing, first of all, you buy the thing and you pull the MBAXP onto your screen, and then it has a little icon. And then you go into Visual Basic Code and you write this code. You set the IP addresses right here. The port number is always 502, timeout, whoopie-doo, and then whether it's connected or not. And then you're done. You run the thing, and then it's ready. And in the background, you set up a polling interval. Typically for analogs, we're doing every second, and for like other set points, it's every 2 seconds or 10 seconds. And then we go we populate the cells of the screen. And I'll show you later on in this video how that's done, but this is how it's done in programming language. We basically figure out whether it's ready. There's a handle that indicates what location that you're pulling, and then it populates. We populate an array, and we take that array right here and we pop it into a range of cells using this application transpose function, which flips it from sideways to up and down. And then we go ahead and put in the date and other stuff. There's a couple things that you have to worry about. Microsoft still has bugs. Like one of the biggest bugaboos, which almost ground this whole project to the halt, was that it would be operating and all of a sudden it would just hang. It'd get slower and slower, and it would just like get super slow and then crash. And we found out that buttons that you put on, like a toggle button from the Excel itself, you put it on the screen, and if you update every scan, pretty soon it gets really, really, really slow, and then it crashes. So the workaround is that we don't update it every scan. We check to see whether the status has changed, and then we update it every time it changes. So when somebody pushes button, pushes the boiler off, then it changes it. That's one bugaboo. There's a couple other bugaboos I'm sure I'm going to find, but I'll go ahead and stop this screen, and I'm going to show you an actual installation at Tascadero State Hospital. This is boiler 3 right now running, or at the time running. And basically this is a balanced draft boiler. There's a draft control right here, and there's a feed water control right there. And all of these cells are being populated. And you can see that you can pop up the draft control system. My fingers are too big. And here's the feed water control system. And then there's another boiler. There's 3 boilers in this complex. They're about, these are 30,000 pounds an hour, 3-burner boiler. This has a burner management and a combustion control PLC. They're both communicating to this Modbus interface. And by the way, the Modbus interface, look at that. That's a Hewlett-Packard 15.6 2-in-1 computer that I just flipped around, made a bezel. And then going into the control room, this is where we have a big Hewlett-Packard all-in-one computer. There's an operator who's irritated that I'm in there. And you see we have another monitor that's vertically mounted, and you've got boiler 1, boiler 2, boiler 2, boiler 3, boiler 4, all in one. He's going to pop up the feed water control system so he can do all the control system. These things are pulling the same address. It's really a very, very simple. And of course, he's pissed off and he wants me out of his boiler room. Get the hell out of here. Anyway, I'm going to go ahead and stop that share. And then I'm going to go over to this other share. This is a remote computer that's running. We decided to use the same platform for our engine controller. This is our 537 cubic inch engine that is the combined heat and power system. We have the same control system there. You pop it up. This is remote, by the way. It's down in Santa Ana. And you go ahead and populate the IP addresses, which you saw in that latest thing, latest slide. And you go ahead and then when you open it up, boom, it's all done. It's like, and there's like about 1,800 data points that are there, and it populates the screen. All these right here, if you look here, these are like just little, you go ahead and point to a cell and it populates whatever it is. Over here, we have the Modbus scaling routine, which, by the way, I have in the boiler control. This is where you take raw min, raw max, engineering min, engineering max, square root, and then all the alarm bits and the trip bits, and basically you can populate all of this. This is populating 2,500 data points. Bam, just like that. Anyway, so I'm going to go back to my other screen, which is the thing and our PowerPoint, and that's if you have any questions, give me a holler. I've been through this ringer for about a year and a half developing all of this. Thanks a lot. I do appreciate it.